Thanks, Jennifer. Aurora tell us in a dramatic way that something invisible is happening above our heads in space to light up our skies. We can use sophisticated Earth-orbiting satellites to learn more about the causes of the aurora. The Imager for Magnetosphere to Aurora Global Exploration, or IMAGE, is a NASA satellite that lets us see the invisible activity that swirls around the Earth and eventually causes aurora to appear. When a solar storm collides with Earth, one of the first signs of the disturbance is a collection of particles called the ring current. It's an invisible river of charged particles extending over 30,000 kilometers from Earth. Much of the matter in this current actually comes from the Earth's upper atmosphere in gigantic plumes and fountains of gas from the polar regions, but we still don't know how the particles get their energy. Another part of the upper atmosphere, seen by IMAGE for the first time, is what scientists call the plasmasphere. It extends out into space at least 10,000 kilometers. You should think of it as the outer limits to the ionosphere. During severe storms, parts of the plasmasphere are stripped off, but then reform as new gas flows out of the Earth's upper reaches. And of course, IMAGE also provides scientists with movie-like high-resolution views of the aurora seen from space. Over the South Pole, the satellite dips down to 1,000 kilometers to show us never-before-seen details in auroral structure. The aurora in the South Pole is called Aurora Australis. Over the North Pole, we see a more distant view and a bigger picture. We can relate this big picture with views of the ring current and plasmasphere to track the evolution of an aurora from cradle to grave. The reason why we're so keen to understand the aurora is that the aurora are kind of like a final examination. If we can really understand how they work, that means we also understand all the other things about Earth's environment as well. We have billions of dollars of satellite technology in space, astronauts living and working in space, and on the ground, many kinds of systems that are affected by solar storms. An electrical blackout in Canada back in 1989 cost billions of dollars. We have lost over $2 billion of expensive communication and research satellites in the last 10 years alone. Solar storms have tremendous potential to cause damage to us. Only by understanding aurora and the events that lead up to them can we improve our ability to predict how to avoid the harmful effects of space weather storms. The real challenge is to get enough early warning that a storm is approaching. That's why it's also important to look at the sun for clues to the next storm.
Thanks, Sten. Okay, guys, now it's your turn to apply data analysis and measurement skills with this really cool activity. Sten, they are gorgeous, aren't they?
Aren't they amazing?